If you pay close attention to how you think, you'll notice an interesting quirk. Your brain actually gets faster immediately after making a mistake. The first time you encounter a problem, you struggle. But the second time, your mind sees warning signs quicker and reacts with less hesitation. This capacity for adaptation is an organic trait. Conventional artificial intelligence operates as a passive observer, waiting for data to arrive, processing it through a fixed loop, and pushing out a response. Look at this linear flow model. When a system relies entirely on an input-output loop, information stalls in a bottleneck. In high-stakes environments like global financial markets, that built-in delay means by the time you receive a command, the opportunity has already passed. A new system known as autonomy bypasses that constraint. Instead of waiting for incoming data to trigger a reaction, it begins its move before the explicit prompts even arrive. By learning to anticipate shifts before they are obvious, autonomy turns artificial intelligence into a proactive force, predicting outcomes based on the earliest whispers of a pattern. But how does an algorithm, built entirely on historical data, accurately predict a future state in an environment that hasn't even happened yet? The solution isn't found in writing faster code. The engineers behind the system achieved it by reverse engineering the foundational steps of human experience. This visualization shows context building. It starts as a single point, immediately mapping the environment into a comprehensive world picture. With this model, it evaluates scenarios, testing how shifting one variable triggers domino effects across the network. Because the system builds this context picture first, its output shifts from a blind, automated reaction into a calculated, strategic maneuver. Getting the initial response right is one thing, but intelligence is proven in the second response. Autonomy uses an experiential feedback mechanism, treating the aftermath of an action as active intelligence rather than an endpoint. A negative outcome is instantly ingested as corrective data to prevent repetition. A positive outcome acts as structural reinforcement, strengthening that pathway for future behavior. This feedback is vital when dealing with data noise. Most AI fails in complex situations because it treats incoming signals like timing, risk, and historical behavior as separate mathematical tasks. Look how autonomy weaves these signals together into a single cohesive framework. Each piece of data becomes part of a larger relationship. Grouping signals into patterns assigns meaning to the numbers. It actively evaluates what is relevant and what is simply background noise. Because every action feeds back into the system to refine the next move, the AI moves beyond executing software and begins accumulating the weight of experience to shape its behavior. In standard computing, there is a hard rule. A sudden increase in variables creates confusion. More information usually means more delay as the machine struggles to process the load. Autonomy defies that rule. When you inject it with massive amounts of chaotic data, the system actually accelerates and becomes sharper. The mechanical logic here is straightforward. Because the system evaluates interconnected patterns rather than isolated tasks, introducing complex new variables simply fills in the blanks of the larger picture. You see this same effect in the human brain. Seasoned experts often think fastest during a crisis because their experience allows them to instantly recognize what matters and ignore what does not. This framework turns traditional computing weaknesses into a competitive weapon. Pressure and immense data loads do not overload this system, they sharpen it. Possessing the ability to build context, learn from mistakes, and thrive in chaos marks a shift in artificial intelligence, moving the focus from raw knowledge toward adaptation. The consequences for global markets are direct. Success will no longer belong to the firms with the most processing power, but to the systems capable of the earliest pattern recognition. In fast-paced, high-risk environments, recognizing a shift early allows a participant to move while the rest of the market is still processing the past. By mirroring the human advantage of adaptation, this system crosses a threshold where its behavior reflects the intuition and speed